Welcome to qnawire.
So now we'll work on problem 40 from chapter 17. In this problem, we're told to assume that 30 milliliters of a 0.1 molar solution of a weak base, B, that accepts one proton, is titrated with a 0.1 molar solution of the monoprotic strong acid HA. In part A, they ask us how many moles of HA have been added at the equivalence point. Now, to know the moles of acid added at the equivalent point, we need to calculate the moles of base that was there at the beginning. So the concentration of base was 0.10 molar, and the volume was 0.030 liters. So if we multiply those together, we get 0.003 moles, which is the amount of acid that has been added as well. So in part B, they say, what is the predominant form of B plus at the equivalence point? So if we have a base which is reacting with strong acid, at the equivalence point, meaning after all the base has been used up, the form of B will be this conjugate acid, this protonated base form, will be the predominant form of the base at the equivalence point. In question C, they ask us, is the pH equal to 7, less than 7, or more than 7 at the equivalence point? So at the equivalence point, this species here is what's determining the pH, and since this is an acid, a conjugate acid, but it is an acid, so the pH would be less than 7, since this is determining the pH right at the equivalence point. And then in part D, they ask us which indicator, phenolphthalein or methyl red, is likely to be the better choice for this titration. So phenolphthalein, we know, has our color transition around pH is equal to 7. So phenolphthalein works around, the transition occurs roughly around pH equal to 7. And for methyl red, the transition occurs from red to yellow around pHs of 4 to 6. And since we're working with an equivalence point with a pH of less than 7, methyl red would be the better choice for this titration.